you to ingest and describe content, and then on the back end, Avalon transcodes the media, makes 3 smaller derivatives to be discovered and then used in classroom, on people's mobile devices, et cetera. So with Avalon, we've always set out to build a product that would be widely adopted by many institutions. So today we're going to talk about how we've approached building a system with other institutions in mind and balancing that with filling our own institutional needs. And just at Northwestern, we've been delivering secure media streams for a really long time. And we're very excited to be this spring beginning the retirement of our old systems and launching Avalon in production to fulfill all of our collections and course streaming support needs.
Just a second.
Okay, let me remember where I was. Okay, so since 2012, yeah, right. Northwestern and Indiana University have been developing Avalon together with funding in part from an IMLS grant. And we have 9 institutional partners who are committed to piloting and contributing to Avalon in some way. And we are part of 2 technology communities, Project Hydra, which is the framework which Avalon is built on, and Opencast Matterhorn, which does the media transcoding on the back end. Since we really want people to install and use Avalon, one of the things we do is reach out and ask you questions like, how are we doing? What is missing? What else do you need? What features would you need to pilot or to use Avalon? We do that through meeting people at conferences informally. We host webinars and send surveys after demoing the pilots and demoing the releases. And most recently, we had a 2-day partner meeting in Bloomington, Indiana. And through these conversations, they help shape our general directions and our immediate priority list. And you can imagine we have a feature list that's quite long of all the things we really want to get done. So for example, one of the things that wasn't on our near-term priority list before partner meeting was the integration with learning management systems. So coming out of the October partner meeting, we revisited our next plan release and added an LTI for Avalon. And I don't have to tell you about this because the Lightning Talk did a good job of explaining what LTI is. Turns out that this really helps our local implementations too. It gets us to be able to securely share Avalon media resources with courses without having to go as far as dealing with querying external systems, making automated groups and all that. It's a much faster way for us to get this done. And this allows us to keep on a tight release schedule, which is another goal of ours. So if we weren't building with others in mind, we would have probably stopped here. LTI has to work with Sakai. But the reason this is important is because each LTI consumer, which is the LMS, Blackboard, et cetera, has its own way of presenting its user and course-specific fields to the tool provider, which is Avalon. So what works for one LMS does not necessarily work for another. So maybe we would have done this in one sprint and been over with it, but instead we iterated on it. As Indiana's LMS is Sakai, and Northwestern uses Blackboard and Canvas, and there are other LMSs out there now. It's configurable. So here's a Blackboard view of Avalon's LTI. If you see the watch course videos, if you click on that, a student or faculty clicks on the link and their credentials are passed to Avalon so that they are already logged in and they see a course-specific view of Avalon. Had we not made this configurable, we could have had a big nasty number that would not be workable for any viewer or user of the system. Another strategy we use to prioritize work is to think about expected behavior and features of a system like this. And one of our first units at Northwestern to adopt Avalon is not in the library, and they really have the need to have embedded video. So in our last release, we built out embedded video, specifically embedded video that had restricted access, so that now you can embed a video, and this is an example of a WordPress site, and log in with your credentials to view the video.
One requirement that came up unexpectedly as a result of meeting with one of our institutional partners, which also happens to be a development partner, were the need for durable URLs. We had not been working in that direction, and then somebody at Northwestern who works in digital collections asked somebody at Northwestern who works on Avalon, how are we going to migrate our handles over to content that we move over from our existing legacy video system into Avalon, and how are we going to assign handles to new content that gets ingested into Avalon? So all of a sudden, system handles became a requirement for Northwestern to install and make use of Avalon, which we could have, I could have put on my Northwestern implementer hat and said, okay, we'll do that on the deployment side, but instead we brought it back into the project and said, how can we make durable URLs, and specifically configurable durable URLs part of Avalon itself. So for example, once we asked Indiana, it turns out they use an internal Perl system that, they don't use handles, so we needed something that would allow generation of and retention of custom durable URLs without being tied to one particular type of provider or making too many assumptions about how they work. The installation of Avalon is also a tricky issue for partner institutions and others who might want to download it. Anyone, is there anyone in this room who has attempted to or successfully installed Avalon or used it? Awesome. No, I mean, that even a small number of hands is a good showing. Because it involves many different components, which I'll get to in a minute, it's potentially spread over multiple servers. Most of them are, right now we have them installed on a single monolithic system, but having our web interface and our transcoding engine and our streaming server all on one server is, you can imagine, not the most efficient use of resources and not going to be a very scalable and usable system. Plus, each component has its own configuration requirements. Not only its own configuration requirements, but we have configuration that uses YAML files. We have configuration that is really code disguised as configuration. We have java.property files for a couple of the components, Matterhorn and the streaming server, Red 5 and Adobe Media Server, whichever one we use, both use these .property files. And there's XML configuration, so that's the only snippet of XML you're going to see during this presentation, but I want, just note that it's there because of the requirement that we include XML on a slide somewhere. And I wasn't going to show our mod rewrite, but since Dre did, I thought, I'll be damned if I'm not going to show my convoluted mod rewrites. This is actually part of the Avalon security layer. It is simpler. And what this is actually providing is the part where Apache receives a request to stream a video, and Apache has to call back to Avalon to say, is this a valid request? Is the token that this user passed valid to stream this video? Because we can't rely on anything like cookies or other user authentication, especially when we cross the protocol barrier, because we also stream via RTMP, and I'm not even showing the configuration that's required for that security. But both the RTMP server and the HTTP streaming server call back to Avalon really quickly to make sure that the streaming request is valid, and this horrible mod rewrite hack is part of how that happens. And then getting this installed and configured is not particularly easy. So like I said, we have both configuration and we have code. The LTI system requires configuration. This is pretty much what's required for LTI. There are secret keys in here, but they are not valid. I made them up, so don't worry. There's also optional configuration to allow the field names to be configured so that if you know what your LMS is sending and in what field names and over what query data, you can configure it so that Avalon knows where to pick up, for example, the user's email address, the course name, the course identifier, the username that should be stored if it's not the same as the email address. The permalinks, the durable URLs, require coding. And if this is readable, this slide, the only part that's really required is down at the bottom, the Avalon :permalink on generate do. Anything that's in there is what is returned as the durable URL for this object, so that this hook into when Avalon publishes an object, it calls this code. If the object doesn't have a permanent URL, it passes the object into this and just says, hey, you know, what's the durable URL going to be for this? Generate me one, or make one up, or tell me what it should be. In this case, it's generating a handle, and it does it sort of in the background asynchronously. It assigns the handle up front, but then actually does the work of assigning it to the handle server in the background. And user authentication requires both configuration and code. The configuration part is telling it what type of authentication to use. In this case, you know, look the user up in this LDAP server. And then the code part says, okay, once the user has been identified, here is how to pull the username and email address out of the response that you got back from the authentication system, subsystem. So again, that's another piece of slightly complicated configuration. There's also customization. This is what Avalon looks like out of the box. It does not look like what Julie showed you earlier with this different header and some different color scheme and some other tweaks that our UI people put on there to make it look more like the rest of our library offerings. And the customization takes place. Here is this is a Git tree, visual Git tree. You can see the purple dots down at the bottom. Those terminate in the current develop branch of the Avalon system, onto which I rebase the 15 blue dots. Each of those is one specific customization that we've made on core Avalon for our deployment system. And every time I rebase, it just layers and use customizations on top of wherever Avalon happens to be. And I can do it on any branch. Sometimes there are conflicts, but usually it's pretty clean. And that makes it a lot easier to do. And we have worked to make Avalon easier than it otherwise would be to do this type of thing, to keep things compartmentalized in this way. So here's the Avalon technology stack. The web app sits on top of Hydra and Matterhorn and Red 5. Hydra is Blacklight and Fedora, and Solar and Rails, you know all this stuff. We have to integrate with the course management systems and websites and authentication systems and everything. And it ends up, if you can see this even at all, this is our dependency. Actually, it doesn't fit on the slide. Hang on. Here, just grab that for me, would you? Yeah, this is our 16-foot-long installation dependency graph, which you know, I'm not going to hold up for the rest of the talk. But if this has been well documented at this point, I'm going to let Julie drag that off to the side there. And this is what I think of when I see that graph. It looks to me like a giant squid. It's destroying everything in its sight. It's just going to wrap its tentacles around and rip everything apart. And what I'd really like to do with the installer is to take that giant squid. It's not going to be simple. It's still going to be tentacly and cephalopody and all that. But it's going to be more of a friendly emoji octopus. You know, it'll behave itself a little better than it normally would. And so we've tried to build admin-friendly installers with some abstraction and customization so that you put your variables in one place and it will write all those different format files and different types of files for you, deployable from any branch, again, if we choose to, based on the shared priority of the developing institutions and the partner institutions. And to do that, we provide 3 different main methods of installation. We do have manual installation instructions, but they scare me They're the squid that's ripping apart the bridge, and it takes about 8 to 10 hours to go through just the script, and that's if you type everything verbatim and don't customize anything. So what we have is a Puppet manifest. Puppet is an administrative deployment system that I don't call them scripts because they don't just run through and execute things. A Puppet manifest is a description of what the final system should look like, and Puppet sort of analyzes the system as it is, takes the system, what the system should look like, and makes any changes necessary to make it look like that. It's kind of spooky magic in some ways, but it is pretty amazing, especially for a system like Avalon. Building on the Puppet manifest, we also create a Vagrant VM installer so that you can download and install a package, unzip it or untar it, and type the words Vagrant up, and in 40 minutes have a running Avalon system on a single box. With some customization, you can, it's just some change to some YAML files, you can spread it across multiple boxes the way we talked about. And we also distribute, based on the Vagrant VM installer, we build periodic OVAs, portable virtual machines that can be imported into VMware or VirtualBox or Parallels that will allow you to just download and get Avalon running really quickly. We also have to build FFmpeg on the fly in these distributions because of license requirements. We can't distribute FFmpeg as a binary. So our installer will install the prerequisites and build it on the fly and all kinds of things. It's kind of crazy. But we've still got some ways to go with it, but we feel we've got a really good start on making it a lot easier to get up and running.
So we are looking to build a community, both for people who want to use Avalon and for those who want to contribute code, feedback, otherwise. We've just started to kind of work out a process, a formal process for this, and we're always welcoming feedback and questions. So please do grab one of us and talk to us. And also, our website has all the information about when you can, sign up for our listserv, download the OVA or the VM, and try it out yourself. I do recommend signing up for our listserv so you can find out about releases, webinars, et cetera. And if you do it now, you'll get in before the release 3, and you'll see, we always do a demo after every release. We also are not, we know that we'll get the most valuable feedback when people actually start using the system. So we're looking forward to tweaking that process and trying to figure it out with other people. We're really also not beyond passing out stickers. And I have stickers at my table along with Hydra tattoos if anybody's looking for those kinds of things. So that's it. Thank you.
Wait, we have a minute for questions if anybody has one. So then we'll move on to our next presentation. And that will be Sustaining Your Open Source Project Through Training with Bess Sadler and Mark Bussey. Wait, can I destroy his last name? Is Mark not here? He's not here. It's just me. Oh, it's just Bess. She's a one-woman show today. Bess is from Stanford. She works with me.
Hello, Code4Lib. Can everyone hear me okay in the back there? Great. So yeah, Mark Bussey from Data Curation Experts was going to do this talk with me, but he couldn't make it, so I'm here on my own. Oh boy. Did that work? All right. Training is an important part of growing and sustaining an open source software project. And I'm going to cover some of the training strategies we're using to grow and sustain the Hydra and Blacklight open source communities. But I also want to talk about how access to technology training is vital to our shared mission in Code4Lib. Training is about growth for a project, it's about sustainability, but it's also vital to the mission of libraries that Sumana reminded us of yesterday. Training is about social justice. For a software project, training allows new people to join the community. Whether or not your project is open source, having a good way for people to get started with it is crucial to new adoption. In the Hydra project, the Dive into Hydra tutorial has become an institution, and part of our process for every new release is to ensure that we update the tutorial. This is a step-by-step guide to building a basic Hydra repository. It covers initial setup, basic data modeling, search, and UI interactions. And by the time you complete it, you should have a working prototype of a Hydra head on your laptop. We offer guided run-throughs of the tutorial as often as possible at conferences, and it's so helpful to have an obvious starting place for developers who want to take things for a test drive. Increasingly, though, it's clear that developers aren't the only people who need an obvious place to get started in the community. I'd like for us to develop similar tutorials for repository managers who need to understand Hydra data modeling practices, and for systems administrators who need to understand how to run the Hydra stack in a secure and scalable production environment. And that brings me to the importance of training for teams. Especially when an institution is adopting a new system, like deciding to implement a Hydra-based repository, it can be a huge benefit for the team to go through training as a team. Hydra Camp is a multi-day curriculum developed and taught by data curation experts, designed to get a team up to speed together. When learning happens in the context of real-world tasks, the way it does when a team goes through Hydra Camp together, implementing a new repository project provides a concrete focus for what must be learned. Training as a team can address local needs, rethink work patterns, and introduce new development methodologies in a way that leaves everyone with a shared understanding of the team's approach. For small institutions who don't have an entire team to dedicate to a repository building effort, participating in a Hydra Camp can be even more important. Public Hydra Camps are offered several times a year, and by learning in a group environment, library staff can gain not only skills, but also a cohort of colleagues at other institutions facing similar challenges, who can be called on for support later. In this way, regional pockets of expertise can form, reinforcing shared practices across institutions, and often creating opportunities for interinstitutional collaboration. But training isn't only important for new adoption. It's also crucial for sustainability. Software changes over time. People change jobs, new staff are hired, and institutions take on new challenges requiring new skill sets. Without a process in place for regular skills upgrading, it's easy to fall behind, feel discouraged, or get in over your head. Many staff deal with this reality by spending significant time outside of work hours, upgrading their skill sets. It's become the norm in many technology shops to expect that people will take care of skills upgrading on their own time. But that's just not a sustainable model. Even people who adore late night just for fun hacking sessions during the legendary larval phase of discovering software development can come to feel differently in a later part of their lives. So these are some of the upcoming Hydra camps. If anyone wants an opportunity to go to Dublin, Ireland, I think you've just missed that one, but you can go to Minneapolis. We also need to face the fact that this is gendered behavior. So this is a tweet from Pax Dickinson, the former CTO of Business Insider, and it says, in case you can't read it, tech managers spend as much time worrying about how to hire talented female developers as they do worrying about how to hire a unicorn. Unlike this jerk, I do worry about how to hire talented female developers. I'm constantly thinking about my hiring needs. I'm deeply troubled about the fact that there are so few women doing open source development, and I want to find ways to change that. For example, I regularly have conversations with people, including many women, who work as catalogers, but feel that their careers have stalled or that they would like to make a change. These people are detail-oriented, have memorized arcane sets of rules, and they understand the importance of good metadata. These are exactly the kind of people I want to hire for my software engineering jobs, and they'd love to make the jump. But when I describe the career transition requirements, they look at me like I'm nuts. The first few times I had this conversation, I said regrettable things like, just spend your evenings and weekends working on open source projects for a while. That's how I learned. I realized what a privileged statement that was after one woman retorted to me, I'm supposed to do that after the kids are in bed when I'm already exhausted? We've got a pipeline problem, so let's build a better pipeline. Here's part of my pipeline. Railsbridge, to quote from their website, is a free and fun way to get started or level up with Rails, Ruby, and other web technologies. Our events focus on increasing diversity in tech so that people of all backgrounds can feel welcome and comfortable in our industry. The curriculum is open source and follows excellent pedagogical practice, breaking tasks down into easily digestible pieces. In fact, they did such a great job with the curriculum that we have intentionally mimicked them in our Dive into Hydra tutorial. The idea being that if you start with Railsbridge, we want that to be the beginning of the learning curve to bringing you into being a Blacklight or a Hydra developer. This was the second year we've offered the Railsbridge curriculum at Code4Lib, and it's been a big hit both times. I hope we keep this trend going. And thank you very much to Jason Rinaldo and to Justin Coyne, who taught it last year and this year. It's not enough for us that Hydra be easy for a developer to get started with. I also want it to be easy for someone who wants a career transition or a change in programming languages to get started with. I want us as libraries to keep investing in our staff. Teaching and learning have been part of the collective vision of Code4Lib since the beginning. Witness this email exchange on the Code4Lib mailing list back in 2006, right after our very first conference. Many of us joined Code4Lib because we had or wanted jobs that required skills that weren't easily obtained, and learning from our peers was the only way to learn. Even now, many of the skills needed to run a digital repository or maintain an integrated library system or sustain an open source software project aren't something you can learn in most universities. Teaching ourselves and each other is a fine Code4Lib tradition, and I am so impressed by the ever-growing number of pre-conference workshops on offer every year at this conference. But the other thing that Code4Lib provides that's even more valuable than structured training is an informal community of collaboration where it's safe for us to admit when we don't know something. The hive mind of the IRC channel and mailing list has saved my bacon many times. Similarly, some of the best training events I've been involved with recently haven't followed a curriculum. I've taught at Railsbridge San Francisco a few times, and the best sessions I've participated in were the ones where people felt free to ask questions, even questions that might be considered off topic in a more traditional classroom. One time, we spent the entire session talking about how the internet works and what an IP address is. The people in the class were having a hard time doing web development without that background knowledge, so we spent our time on that, and it was time well spent. Similarly, when I got the bright idea this year that I was going to offer a Railsbridge class at the library where I work, The actual Ruby on Rails content was a total failure. Turns out, none of the people who showed up particularly wanted to learn Ruby on Rails. They just wanted access to technology training, and this is what was on offer. As soon as that became clear, what we ended up with was a regular informal session focused on the frustrations some of our staff had with their jobs, collaboratively coming up with solutions that were immediately applicable and grounded in their daily work. For those of you who are new to Code4Lib, welcome. This is a safe space to ask questions. This is a place where you can get valuable technology training and even more valuable informal mentoring as you navigate the sometimes arcane world of library software. And for those of you who have been here, thank you for the questions you've answered for me and for creating this space and for all that you do to sustain this community so that we can continue to grow the community of people who can sustain libraries. Thank you. So apparently we have time for questions. Oh, come on, that was a little controversial, wasn't it? Yeah, Sumana, here we go.
Thank you for making me cry. That was wonderful. I wanted to take a moment, maybe give some people a little bit of time to formulate their own questions by sharing a couple of resources. I'm so happy that RailsBridge has been helpful on this. I think we're seeing a bunch of people sharing best practices in creating these kinds of openly licensed, really grounded in layperson-friendly pedagogy tutorials, both online and to do in person, right? So the RailsBridge work that you kind of keyed off of is one of them. The Open Hatch curriculum for their one-day boot camps. Open Hatch comes to campus, and for instance, Boston Python Workshop for Women and Their Friends curriculum is another one that's helpful to use that people can just grab and use at their own campuses. There's also a useful set of tools that I found nice at Hacker School, which is a set of 4 social rules for how to set up these kinds of learning spaces in such a way that everyone feels safe to ask these kinds of questions. And I'm sure there's even more popping up all the time, like the software carpentry guides for scientists who are getting into programming and so on and stuff like that. Were there any other resources that you wanted to point people to, maybe if they're using languages other than Ruby and so on?
Yeah, I've been particularly impressed with the work that Andromeda Yelton has been doing in LIDA and the Year of Code and ALA, the coding workshops that have been taught a few times at ALA now, including a bunch of stuff that happens online via Google Hangouts. I think that that's very encouraging. The world of coding for libraries has been a bit of a self-selecting group traditionally. I mean, you kind of had to really want it in order to get in here, and I think it's great that we're expanding that. I love the work that LibTech Inclusion is doing around reaching out to communities that aren't necessarily traditionally technology-focused, but that do a lot of technology work. Becky.
A resource and a possible discussion for you and me afterwards. You mentioned one of the things that has been one of my interests for many years, which is getting catalogers into more of the technology, more into coding and whatnot. Just for letting catalogers know or metadata people know, there is a little small cataloging community that is trying to do coding, and that is cat code. There is a wiki, there is a libcat code QA, so ping me if you want more information. And one thing that I just want to throw out there is that taking people from technical services, and I do want to say a controversial statement, there is a class system within librarianship, and technical services is on one of the lower rungs, and trying to get them up to where they have tech privilege, and I've experienced this myself. I know I have privilege that I have tech privileged now since I have the skills than I was, identifying as a cataloger. So I just want to throw that out there, and it'll be interesting to discuss with you later on about that. And pay. Yeah.
What was the last statement? And pay. Oh, and pay.
Yes.
No joke. Yeah. No, and that is a really important point. It's a little controversial to talk about. Coders make more money than catalogers. And they do surprisingly similar work.
Yeah.
And I knew the Q&A was going to be the best part of this talk. Thank you so much, Becky. Yeah, over here. Hi.
Hi, I'm Mike Beccaria. One of the things as I was learning to code and come into this community, I have an undergrad in history, which isn't really helpful in that context, but the resources that I found most helpful were ones that go from start to finish. That is to say, don't assume any knowledge on the end of the user, and one of the ways to kind of present that, and I'd recommend this to anybody here who's developing and you're uber geeky and you're making cool stuff, is to make screencasts from a clean install to a finished install. And then everybody in between can see how you did it from start to finish. So that's all.
Great, thanks. Hey, Artie.
I guess this is a more general kind of thing in terms of learning to code and whatnot, but my struggle was not so much finding something that kind of does the really basic, assume that you have no knowledge. Mine was really finding resources where I don't want to learn about variables and functions and if-else statements for the 100th time because I already know that. But what if I want to learn more about a language that I don't know anything about, but I already have the basic fundamentals of programming? And that's actually where I've struggled, really. And I do really like the Railsbridge one because last year when Ronaldo did it for us, I'm like, oh my God, you already assumed that we have some knowledge of how systems work. You're not explaining all of that to us again as if we have absolutely no knowledge, because we do. We just need to learn what Rails is, right? And that was really great, and then I would really love it if people could share other resources where you find something similar, where someone who already has kind of that basic knowledge but just doesn't know the language could really learn how to kind of pick it up.
Yeah, that makes a lot of sense. And as great as it is when we offer Railsbridge here, it's a small enough audience that we have to kind of focus on a specific target. If you have an opportunity, there are not only Railsbridge, but lots of similar kinds of workshops cropping up around the world. And those can cater to a wider, you can have like both a really beginner section and a I'm just learning a new language section. Mark.
So I think this is a little bit of a different direction with this question, but thinking about those of us who are placed within our organizations to, who are managers or trying to cultivate a community within our organizations, I'm looking for feedback or guidance about how to build this culture, and so where I work is different from a lot of places, but it doesn't mean it's necessarily extra special. But I think we've got a lot of opportunities right now. So I think it would be useful to hear what types of things have been useful, those of you who are trying to do this in your organization, regardless of the type of library that you work in. And the more that we see that these are not, some things might work in academic libraries and some things might work in public libraries better. I'm curious to hear where we will find ourselves needing to do the same sort of advocacy or education within our upper level management. And that's, I think, that's not what I have right now. So that's kind of rambly, but I think I had a point. And it was a question, I'm sorry.
I'm trying to distill that into a question.
So am I.
What I'm coming up with is maybe what works. Targeted recruiting works. Codes of conduct work. Workshops that are built on making a more inclusive community work. There's lots of other stuff that works. We're very lucky that tomorrow we're going to have a wonderful keynote speaker who's going to give us a lot more information. The ADA initiative works. All right. Thanks so much, everyone. Bye.
So next up, we have Esmé Cowles. My cousin's last name is spelled the same. And he's going to present Behold Fedora 4. I feel like it should say, Behold! Behold Fedora 4, the incredible shrinking repository. He is from UC San Diego.
Well, now I need to find my actual presentation, which has moved since I looked at it last. Any ideas? It's called ESCols-FF, but I'm not seeing it.
Not seeing it either. Do you still have it on somewhere else? I can stall.
Yeah, let me see if I can load it from Dropbox or somewhere.
Michael Klein,
Yes.
can you give away a book so we can stall?
I could also give away a 16-foot poster.
Oh, I had a question about that poster. Was it created in OmniGraffle?
It was created in OmniGraffle.
How do I mirror? You can use a wireless mic too. I'm sorry, how do I mirror? I need to see what's on the screen. Okay, that's fine. Because I can't. Oh, you're fine.
But I'm already here. I'm going to elbow my way. Oh, okay. All right. Who wants a book? I'm not going to do that I can't hear you thing. I don't have that kind of energy. Eric Mitchell gets a book. Eric Mitchell? James Hill? Is there a James Hill? Oh, I wish I'd done the O'Reilly announcement like Oprah. You get an ebook and you get an ebook. Everybody gets an ebook.
All right, your last chance.
Somebody please just win. James Hahn?
Now they're just screwing with you.
Is this the list of people in this conference? Sandra Bullock. Is there a Sandra Bullock? Steve Shane? Schoen? Schoen?
All right, we'll give up.
Sheen? Oh, wow.
Jimmy Hoffa?
That was the best song.
Oh, so apparently this is a fail for live breakout. Hi, I'm Esmé Cowles, and I'm here to talk about Fedora 4, but I need to start with a confession. Fedora is a very popular repository, and it is the foundation of Hydra and Islandora that we've heard about a little bit. It's used by many of the people in this room, but not by the university that writes my paycheck. And there are actually several Fedora 4 developers in the house. Ben Armateur, Greg Jansen, Chris Beer, Adam Soroka's here, and they all use Fedora in their real jobs, and I don't. So I just thought I'd put that out there. So at San Diego, we have our own repository. We've cloned a little bit of the Fedora 3 REST API to put a Hydra head on top of that. And that's working out pretty well for us. We considered other options for integrating and other options for using Hydra, including writing our own adapter layer, our own client library. But we decided to go with that clean separation of the API, and it's worked out really well for us. But I am working also on Fedora 4, and so I feel like sort of an unlikely spokesman for Fedora in general, but maybe a really good one for Fedora 4 as someone who's interested, who's not using Fedora 3, but maybe is coming to Fedora 4 and starting something new. So I had a somewhat pepped up presentation proposal and with some big promises. Let's see if I can fulfill them. First and foremost, I think, is performance. Coming new to the Fedora Hydra community, I heard a lot of complaints about performance. About you can only load files of a certain size. If you're dealing with video or other large files, you have to host them separately. Or how many objects you can have, or how slow ingest is was a common refrain. And Fedora 4 has really gone a long way to address a lot of these bottlenecks. The REST API can now handle files of any size. I've done some work testing that with files that are a terabyte, and I really just stopped there because I've heard of very few people with files that size or bigger, and it takes, you know, hours to move a terabyte around. You can put tons of objects in Fedora 4. Ingest performance is much better, often twice as fast as Fedora 3. And if you already have files on disk, which is a common scenario for big files, you can just use the file system connector, and ingest takes no time at all. There's no extra step. And if single node performance doesn't do it for you, Fedora 4 is built on the ModeShape JCR repository, which has built-in clustering. You can do horizontal clustering to have multiple ingest servers or multiple read servers. And hopefully we'll get high availability clustering working too, where you can have failover and redundancy that way. Flexibility is another really big advantage of Fedora 4. You know, Fedora 3 has a very flat, fixed schema where you have a flat list of objects and you have a flat list of data streams. Fedora 4 gets away with that restriction. You can have any hierarchy you want. You can have multiple storage backends, so it's really flexible on how you store the content. We're working on asynchronous I/O so that you can have support for Glacier or HPSS or other systems like that to pull that systems in. There's a pluggable authentication, a pluggable policy storage module where you can decide to have little bits of logic that'll say, these kinds of files go to this storage resource, or these kinds of files go to that resource, or you can configure modules that get triggered when you upload certain kinds of files. So there's a lot of different ways to do things to get the tasks you need done and get them done in the repository, get them done automatically, get them done in a way that clusters and scales. And also authentication is a new area that we've been working on recently to really get flexible authentication into the repository in a way that people can really use. And if that's not enough for you, you can have entire other systems swallowed by Fedora 4. It's called federation or projection. You know, if you have files on disk, you can configure that to be projected into the repository, and it's just there. It doesn't take extra time to load. It's fast. It performs almost as well as files that are in the repository, and they become first-class objects in the repository where you can do fixity checking. You can set properties on them. You can use them through all the regular client libraries. If you have a Fedora 3 repository and want to migrate content, you can federate your Fedora 3 repository and use that as the springboard to either serve the content where it is, if you want to keep that Fedora 3 repository around for a while, or to copy the content over. And like everything else, and this is a real theme for Fedora 4, it's pluggable. You know, we've written those two modules, the file system and Fedora 3 modules, but it's not difficult. It's not a ton of code. You can write this for any other system. If you've got another system that you have that's providing, you know, a good service to you and you want to keep it around, but you'd like to have that repository, that content available in the repository too, you can write a connector to pull that in. RDF is sort of the language of Fedora 4. It's not a triple store itself, but it speaks RDF. When you ask it for properties, it gives you triples. There's metadata everywhere. Every node, every part in the hierarchy can have properties attached to it. You use Sparkle Query and Sparkle Update to change properties and add things. And so it's not really a triple store, but yeah. And if you need a real triple store, we have an indexer. Unlike Fedora 3, where there was a triple store sort of baked in, and it slowed things down, and it tied you to one particular implementation, Fedora 4 has that separated out at a nice, cool distance, where it sends messages, and the indexer can listen and do anything you want with those messages. We have code to copy the Fedora 4 triples into Jenna or Sesame. Any other triple store that uses Sparkle Update 1.1 should work with just a small amount of configuration. If you have another triple store that you want to use, it should be easy to write a module to support those two. Of course, a lot of people want to search and index things automatically in a search engine like Solr or Elasticsearch, so we have modules for those. And again, pluggable. These things are not complicated to write. They're not complicated to hook up. Anything that you want to index things to, or if you want to save things to disk or send them off to a preservation repository or generate an audit log for them, there's a lot of different options and possibilities there. We've also worked really hard to make it easy to use. You can go to GitHub and download a WAR file. If you just want to try it out, you just double-click the WAR file. It's got an embedded servlet engine. It starts up and runs on your local host, and you can get going in literally seconds. If you have your own servlet container, you can just drop it in there, and it's a regular WAR file, and off you go. If you want to change the configuration, there's not a huge directory of boilerplate that you have to set up and maintain. If you want to change one property, like the directory where the data gets written, or whether you're going to use this kind of storage or that kind of storage, you can set a system property. You don't have to have a huge, complicated configuration file to maintain. You can literally just have the directory on a system property to put that somewhere else. So you only have to maintain the configuration that you're really using. The future, of course, is always a little murky. Andrew Woods, the tech lead, wanted to make sure that I reminded everyone that Fedora 4 does not have any committed, employed developers working for it. It's all volunteer effort. All the people I mentioned before are paid by their own libraries to work on Fedora 4 because they value Fedora 4 and they want it to be advanced and improved. We've got an Alpha 4 was just released earlier this week, and with a lot of new features that are now rock solid and ready for people to test. We plan to have a beta released by Open Repositories in early June, and after that, it's really a matter of how much testing and pilot project and documentation people can help us with. That can happen very quickly if enough people help us and if we get the right kind of engagement. I think Fedora is very much the plumbing in a lot of our lives. It's out of sight, it's out of mind, chugging away in the background. Now is the time to open the cabinet door and make sure that the pipes are doing what they're supposed to do. Make sure that things are really how you want to be, that this new software meets your needs and works the way you want it to work, that there aren't gaps that need to be met. And I'm not just talking about coders. Coders are great, and coders help get stuff done, but this is really everyone. Every user of every kind can look at this and see if there's a circumstance that we haven't thought, if the documentation isn't complete. You can set up something on your local machine and test out that feature that's important to you and tell us about it if it's broken. You can document the things that you need from the repository so that we know what to test. So here's some of our contact information, and I left plenty of time for questions if anybody has any questions. They're phoning it in. No? All right, thank you.
So, our next group, because it's a group, a reusable application to enable self-deposit of complex objects into a digital preservation environment. It's Jill Sexton, Mike Daines, and Greg Jansen.
Yes, give away a book. Go ahead and set your output resolution to 1024 by 768 if you can.
Randomizing as I walk.
It's not? Oh,
That's not. I was trained in the theater.
Carrie,
Rachel
you need the IP
Trent?
address?
Yay, somebody's in the room.
$192, $168, $020.
Am I giving away another? Declan Syke, no, Emily Brassel.
I'm flying blind though. I'm gonna have to just. That's all right.
Yay. Hold on. Well, clap for him. You got it, Carrie? Okay.
Hey, good afternoon, everyone. I'm Jill Sexton, and Greg Jansen, Mike Daines, and I are part of the team responsible for the development and user support for the Carolina Digital Repository, which is the preservation repository for UNC Chapel Hill's libraries. It's a Fedora repository backed by iRods, and we preserve student and faculty research in a broad sense, as well as born digital archival content in a wide variety of formats. And today we're going to talk about an application we built to enable patron self-deposit of multi-part objects into our digital preservation environment, or as we call it, the Forms app. So I'm going to talk about why we built it. Greg's going to talk about how we designed it. And Mike is going to talk about how we're making it better and more usable for the wider community. So what's the problem? So repositories, I think, often use web forms as a way to enable patron-initiated ingest of simple, predictable content. The problem is that these generic web forms that we create are just that. They're generic, and they rarely serve any specific kind of content very well. They're just a basic kind of black box. So we felt that we could do better. So we think that better forms are targeted to a specific audience and can more precisely describe a certain type of deposit. For example, an academic paper, a conference poster, a work of art might all benefit from slightly different descriptive fields. And so we designed this Forms app in response to a need to regularly and rapidly create custom web forms to enable self-deposit. So for example, this is a form that we developed to enable student deposit of undergraduate honors theses at UNC Chapel Hill. You can see that there's a logo at the top of the page that lets students know that they're in the right spot. And the metadata fields on the form are tuned specifically to include information that's important for this collection. So, and yet, we did quite a bit of customization on this form, but for all of that, it's still a pretty straightforward form. It's got a basic, title, author kind of elements, and the uploads required is only a single file, and maybe a single file with an additional supporting signed cover sheet. So in contrast to that simple form, I'm going to describe a use case that's one of our most complex ones to date. So that's support for student ingest of studio art MFA final projects. So I'm going to describe the situation, and I wonder if it's something that many of you can relate to. So we were approached by our art librarian, Heather Gendron, in the fall of 2012 about the possibility of preserving these works in our repository. So up until this point, students had been submitting paper copies with a CD that contained digital files supporting their work that were put in a binder and stored in closed stacks in the art library. The digital files that were a component of of these works were not under any kind of preservation control, and the papers required staff intervention and mediation for people to use them. So Heather contacted us about putting the files in the CDR to preserve them and to make them more easily accessible to people who wanted to see them. So these were easily some of the most complex objects that we have attempted to work with up to this point. So they consist not only of a paper and PDF, which we can handle, but they've got up to 20 supporting files that represent the work, which are mainly high-resolution scans, so read big files or photographs of works. And less often, they included things like audio or video files for students who work in video art. And in order to meet her goal of enhanced discoverability, each of these files and supporting works need a description so that people can find them. And it quickly balloons. The library doesn't have the resources or the desire to do original description on each of these works. So clearly we need the creators to upload and describe their own work, or we just can't make this happen. And furthermore, in the case of this project, we really feel that the artists themselves are in the best position to provide meaningful description for these works, like abstracts describing what they were trying to get at when they made the work, or even something like listing the materials that they used in the creation of the work. It was also important to us that the collection owner should have a hand in helping to define the inputs present on the submission form, since they're the ones who have the domain expertise in this area. But at the same time, we realized that we had to balance the desire for everyone to have their own special custom form with the fact that developing forms as a single-purpose application is a slow and error-prone process, and it's a poor use of scarce developer time. So we came up with a couple of solutions that work together. So the first is an application that lets non-programmers develop web forms, and that includes mapping plain text labels to mods elements. Mods is a descriptive standard we use in our repository. The second piece is a web app that presents these custom forms to users, takes their input, transforms it into metadata, and submits the deposit into our environment. So how did it turn out? So we've been using and expanding on this Forms app for the past 2 years, and we're depositing increasingly complex objects using it. In the case of the art project last spring, we had 9 students, which might not seem like a lot, but it's everyone in the program, successfully deposit their works as supplemental files and associated metadata. We consider this a major accomplishment because of all of the technical issues we had to resolve in making this happen. And I think one of the benefits that we weren't anticipating was that the requirement for all of these students to deposit their works in our preservation environment before graduating really provided an opportunity for our art librarian to begin talking to young artists about the need to preserve their digital legacy. And this has become an area of big focus for our art librarian, and she's really made it part of her job to spread awareness of the need to preserve your works among her user population. I think that for those of us who work in digital preservation, this is kind of the dream that we all have, that our liaison librarians will take up the torch for us and start doing that work of outreach that we enable, make it easy for them to do by developing tools that help them get this done. So, Greg?
So as you could see from the MFA slides, that those requirements really stretched our original design beyond this simple form with one file and a set of fields that map to mods, in our case. Some of the requirements here are the repeated fields, so multiple faculty advisors or multiple authors, things like that. Access controls, such as embargo dates and assigning roles to people. Also, the supplementary files with their own metadata. We also had to implement the controlled vocabularies, and interestingly, vocabularies that were tied to extra data, so that we could say, pick your department or your major, and then from there we would know who the reviewer should be, who should get an email when this deposit goes through, and that sort of thing. This should probably just say overview. We've gotten this far in Code4Lib without an OAIS slide, so here you go. This is just to situate where we are in the grand scheme of things. in the submission information package process there with the producer and the ingest. So our Forms app makes a package and submits that via SWORD to the ingest service, which puts it in the repository. We develop each individual custom form in the tool called the Curator's Workbench. So you define a form there, and then we upload it to the server, and then the server presents forms to depositors. Yeah, there you go. The students depositing their PDFs and TIFFs and what have you. And so the submission information package is traveling there along the SWORD protocol. Those not familiar with SWORD, it's sort of a brand of AtomPub. And what we're working on now is replacing the Curator's Workbench authoring with web-based authoring, so that you'd have a web form for developing your form or a web app for developing your form, just to simplify things and make it more reusable in other places. And with that, I'll turn it over.
So I'm going to talk a little bit about, Greg talked a bit about the architecture, but I'm going to talk about how we actually create these submission information packages. Sorry, can you hear me now? Thanks. I'm going to talk about how we actually create the submission information packages. So we have a form definition made in the Curator's Workbench that tells the Forms app what fields we want to display. These are linked with objects in a structure representing XML metadata, in this case mods. Here we've linked the first name to a mod's name part element inside a name element. So not quite XML on the screen, but. So when a user comes along and fills out the form, the values they enter are just copied into the metadata structure. The Forms app then builds a structure representing METs, our sort of structural metadata format that we're using, which embeds the metadata and links files to that metadata. Finally, we serialize the METs as XML, package everything in a zip archive, and submit that via the SOAR protocol that Greg mentioned. So what about reuse? We want users to keep using our forms, but we may want to change how our packaging format or submission protocol works in the future. Also, we want others to be able to use this work, but obviously not everyone uses the same architecture or metadata formats or structural metadata formats. You may use a Dublin core, for example. So we're working on ways to open up parts of the app to modification. First, we're rethinking how we generate metadata. We're moving towards a form having a template for each kind of metadata document that we want to deposit. So we could have a template that renders a list of authors, for example. This isn't tied to a particular, our model isn't tied to a particular metadata schema, but we render a text-based template. And instead of linking form fields directly to a model of our metadata, we're representing user input in a structure like this, which is sent to the template for rendering. So I talked before about how we generate METs and then submit via SWORD. We're abstracting that away by offering two interfaces that we're using. Customization of deposit behavior would be done by a developer implementing these or choosing an existing implementation. We have packagers which arrange metadata in digital objects, and for us this corresponds with generating METs and choosing locations for uploaded files. And we have submitters which actually submit the package. This is the part where we zip everything up and submit to the ingest service via SWORD. We'll have our own implementations when working on general ones as examples. So I'd like to give a bit of a tour around the Forms app if it works. We'll see. Is that showing up? Good. Okay, so this is a simplified, oops, I guess we're not going to give a tour. Oh, that's okay. It's I'm just going to. It's in a VM, and we seem to have some problem with the VM. So I'm just going to show a screenshot of a simplified version of our StudioArt MFA thesis deposit form. The student fills out their first and last name and can add can add any number of slides assigning metadata to these. This is what our deposits look like when they get into the repository. We have the metadata describing the entire deposit and the associated objects. And here's one of those objects which has specific metadata assigned to it. So our code for all this is available on GitHub. And thank you. Here are the image credits that we used in our presentation. Yeah.
About 7 minutes for questions.
Okay. Why don't you guys, any questions? Yes, question.
Hello? Okay. I'm just curious about, are you testing for the images or the technical metadata you extract from the images that are submitted through the zip package?
Sorry, what was the question?
Extracting the technical metadata from the, I think the student can submit images or something like this. So are you using any tool for extracting the technical metadata from those images?
We are, in fact, that's not a part of this process, but it's after the packages get ingested, we process them to extract technical metadata.
Yes. Which tool you are using for extracting the technical metadata?
What tool are we using?
Joe?
We're using FITS. Yeah.
Sorry?
FITS.
FITS?
Yeah. The file information tool set from Harvard originally, and I guess OpenFits now. Sorry, the file information toolset from originally developed at Harvard, I believe, and then OpenFits. And I think we're running Droid and Jhove within that, and the file utility. So there's a number of different tools that it packages, but it's sort of a meta tool. It runs a number of things.
Okay, thank you.
And indeed, we run that on every file we put in the repository.
I wanted to add one other thing to that, is that we're looking for input. So if there are things that, if you think this tool could be useful to you, please come and talk to us afterwards. We're looking for input. We'd like to make this tool useful. So if doing some kind of pre-processing of these files before they're packaged up in METs and zipped up so they could be placed anywhere, would be useful, please come and find us. We're nice people. We'll talk with you. So.
Just a quick question. Could you move the slide back like one so we can finish writing down the URL? Thanks.
Right on.
Hi, Roy Tennant, OCLC. Did you look at ImageMagick at all to take metadata out of images? And if you did, how does that compare with FITS? Just kind of curious.
We haven't looked at ImageMagick for that purpose, so we haven't done that comparison. Yeah, but yeah, in this submission process, this metadata is submitted by the user, not extracted, in fact.
We do use ImageMagick to create derivative images within our repository infrastructure, though.
Anything else?
Nope. Thank you very much.
Thanks.
So next up on our schedule, unless somebody tells me I'm wrong because I haven't looked at the schedule, but I'm pretty sure we're going to have a break. And then at 2:40, thank you, we're going to start breakout sessions. I have the breakout sessions in my hand with rooms for each of the breakout sessions. I did my best to interpret people's meanings. If I was wrong, I apologize. And then we come back at 3:30. We have another break, which lasts until 3:50. Look at that. It's like coming right out of my brain. So we'll be back here at 3:50, at which point Michael Klein will again attempt to hand out books, and we will all laugh. Oh, and I will be standing here holding this because this doesn't have a sticky back, so, just come up and look by. Or do you guys want me to read it off? I'll read it off. Yeah, somebody else will have to do that. Digital preservation is going to be in Governor 1. Solar is going to be in Governor 2. UX, again, is going to be in Magnolia 1. Securing Easy Proxy in Magnolia 2. Text Service Projects is in Pin Oak. Angular is in Capital. BibFrame 2 and linked data is here in the ballroom. Unusual searches and or long query strings is in Willow Oak. Raycarta is in here in the ballroom. And the OCLC Institutional Registry RDF project is here in the ballroom as well. Sound good? Can I just take a picture of that real quick? You may. So again, breakout sessions start at 2:40. Thanks, Becky. Here's what I'm thinking.
built on NSIP. However, even within some of the same software and services, we build other APIs from the ground up. NSIP is a standard that defines, that leverages HTTP for transfer of messages back and forth, but those messages are highly prescribed by the standard itself. What we're discovering is that for the machine-readable services that we create, our data is the API itself. For the things that run the business of libraries, creating purchase orders, submitting payments, cataloging things, getting item availability, a model of allowing clients to do simple requests and assertions for data back and forth, to request and assert resource representations, to manage application state is
Am I doing what? Are you ready?
I think we're ready.
Okay.
Okay.
Let's leave it at 1.
Thank you.
Just
You're
let me
welcome.
let me get a confirmation from Carrie. You got it?
Do it again. Do it again.
Quick, give another one. Aren't you guys glad we get to set this up? More books.
Carolyn Cole. Penn State in the house? Carolyn? Oh, someone else to harass about not being here when a name came up.
Yeah.
Oh.
The Rosenfeld books are print books, not ebooks.
Yes, hence the need for your address, so they can actually mail it to you. They cannot email you a physical book, unfortunately. Okay, so.
That'd be amazing.
Steve Segedi? Segedi? I have found that people are very forgiving of pronunciations when you're giving them free stuff.
192, you got it?
Got us? Great. Awesome.
All right, thank you.
Thank you, Michael.
Okay, so here we are. We're going to show you real quickly how you can test your JavaScript heavy UIs. So, and we're
Right.
going to do it right here.
Yes, this is going to be live code, so I'm sure
Yep.
lots is going to go wrong.
Yep.
But we are
So-
prepared for zero network access if that
Right.
happens.
So here we go. I'm going to just start up a nice little simple web server here. Can you hear me?
Can you hear both of us?
And here we got this nice little page, thanks to Zerb Foundation, one of their samples, and it has JavaScript validation on it. So I do things like that, hit submit, and it's great. I got a twill test. It's testing that all the right text is coming back. But how do I know that when the user interacts, these red boxes show up when they do something wrong? I have no idea.
Right, because it's all running in the browser, so the server never sees the red boxes.
Right, exactly. So let's see. The first thing I'm going to do is I'm going to go to Selenium HQ and download the Selenium IDE. This is a great tool for getting started with this technology. If I can find it here. There it is. And I'll install it into Firefox right now. Boom. Restart. Okay. Back up. And now I go down to my web developer tool. And at the bottom there's Selenium IDE. And it is in record mode, so I'm going to start doing some stuff on my page here. I'll submit it. See all the nice red come up? Let me put a password in there.
It's actually recording what he's doing into a test script
Yep.
right now.
What do I need? I need that. Boom. And chilies, okay. And now I can submit it, and it doesn't do anything. There's nothing backing it. But you see that, and now I'll pop back to the Selenium IDE, stop recording, and now I'm going to export this as first a Ruby test unit case with WebDriver. If I can type, oops. Test, and now I'm going to do one for Python with the WebDriver unit test.
Can you also show it running here?
Yeah,
like
yeah.
in the
Let me do
IDE?
that. Let me do that. So, and once you have your little IDE script set up, you can drive the whole sequence from the IDE. So, let's see it do its. There it goes. I'm not touching it really. Okay, so there we are. So that's the Selenium IDE.
So that's a way that you can get a start on a script, and you don't have to know like every ID of every item that you're going to fill in.
And now I'm going to try to run that script that was produced that I just exported. And, okay, come on. Oh, it worked. It wasn't supposed to work. So I'm not supposed to have Selenium installed, but unfortunately I do. But okay, so pretend I didn't have Selenium installed and it didn't work. So I'm going to set up a virtual env, and if anybody doesn't know what that is, this creates a new Python install, essentially, that doesn't have any of the stuff you set up on your system. So when you start a new project, you get like a green field of like the Python configuration. And as you install libraries one after another, at the end of your development cycle, you just say pip freeze, and you get a whole list of the requirements for that project. So it's a real handy tool. So in this environment, once I activate it, this will fail. So boom, and I do Python test. And no module name Selenium, so I better install Selenium. There it is. Boom, and I run it again. Come on. And there Firefox pops up, does its magic. That's great.
Now, we're not really testing anything, right? It's just
Yeah,
typing
it's just
stuff
random,
in.
Right, okay, so let's make a
You
test.
haven't proven that validation is working.
Okay, so what do we want first? A failing test, right? Okay, so right before the submit, I know what I'm going to do here.
Okay,
So,
before you click.
assert. This is before I click the submit button. Driver, find, element by CSS.
So there's a bunch of ways you can find elements.
Mhm.
CSS selectors are a pretty handy method for doing so, but you can use IDs or all kinds of ways.
And now I'm going to say is displayed. So is that red box displayed?
That's the CSS selector of the first red box, essentially.
Mhm. And now I run this again. Oops, ba-bum. And it goes. And there it is. There's my assertion error. False is not true. It's not
Failed,
displayed.
which is what we like to see.
So now we have a failing test. We know we ran the test. Everything's great. Failure never felt so good. So, so now I'll just change it. I'll put it after the submit, and I'll add an assert false before, and this should pass.
So
now.
before the click, there should be no red box.
Mhm.
After the click, there should be a red
And
box.
I'm asserting it on either side, because here's my submit click right there at this line. So I've added a false and then a true. So hopefully this will work. See, it takes a little while to fire up the Firefox web browser. And sometimes it's a long while. So there we go. And there you can see it do its magic, and it worked.
Test passed.
Beautiful.
Congratulations. Good job,
Yep.
Gary.
All right. Now that was for the Python side of the house. Now Martin's going to do the Ruby side of the house, okay? So,
All right, so here comes Ruby, which is sitting here. There it is, Ruby test. So the Ruby code that it generates is pretty similar. Unfortunately,
the code generator has a bug.
The code generator actually has a bug.
So-
Everywhere that it says $receiver here has to be changed to
at
@driver.
driver. Then it'll run.
Okay, so we're going to do, well, let's see if it actually runs first.
Yeah, for sure.
Failed. We don't have the Selenium WebDriver. So
Uh-huh.
We're going to gem install Selenium.
Yeah, so there's a standard gem for Selenium, and then there's a PyPy library that you can easily install for Selenium in Python. So they're all out there freely available, of course. So.
And I'm not going to install the docs because they take a while to install. Usually this doesn't. Oh, wait.
There you go.
Yeah, there we go. Okay.
And we're working on Windows just to make it painful for ourselves.
Yes. Originally, we were actually
And you can
gonna-
do it, so you can do this if you're a Windows person. It's
Originally,
great.
we were going to do 2 computers during this presentation, then we realized that would be twice as insane. Okay, so test ran. I'm going to go through the same process in Ruby of
adding an assert so we
adding
actually
an
see the
assert,
failure.
right.
Always got to fail a test, right? That's the first thing in testing. Make it fail.
So we're going to, everything looks a little different in Ruby.
Mm-hmm.
So here's the CSS selector. What if I wanted the second red
If you want the
box?
second, so these Selenium drivers have all sorts of functions, and It's kind of a little tricky. If you want a whole list of the selectors, you add an S to the end of the function name. That is fraught with danger, in my opinion. But oh well. So you can't get a hold of all of the various elements.
Elements, plural.
Yeah, well, it's CSS selectors, I believe.
Okay.
And then you get a list back of all the ones that match.
Here we go. So
And-
test failed. Yay.
Awesome.
And then finally, we're gonna go make it succeed.
Mm-hmm. But you can see there's like a big lag startup when Firefox fires up. So if you're doing a lot of commits and you're testing like you should be after every commit, it can get kind of slow, especially if you have a bunch of these tests running. Now this is kind of more on the functional acceptance test end rather than just a basic unit test. But before I push any code to production, you got to do something like this, right? You got to make sure it works in the browser.
All right, so the test passed. And by the way, if you were on a Mac or Linux machine, this should actually be all colored in green text.
Yeah, it gets green and red and stuff. Windows,
Red for fail.
you don't get that luxury in Windows,
Whatever.
So, oh well.
All right, so how do we make this faster? And what we're going to do is run the same test using something called PhantomJS, which Mark can describe while I install it.
Yeah, PhantomJS is a headless web browser, so it doesn't have any UI. Pretty sure it's based on WebKit, so it's similar to a number of browsers that we use every day. And the great thing about it is there's a binary for Windows, Mac, Linux. You just unzip it, put it on in your path, and you've got it. That's it. Really easy. You can compile it yourself if you like that sort of torture, but
Really? But it honestly takes several hours to compile.
Okay,
so
there
don't do
you
that.
actually did it, huh? Good
Yeah.
for you.
Okay. So I unzipped it, and you can move the executable wherever you want.
Yes.
I'm going to leave it right here.
Yep. And then you got to change your test, right?
Oh, right. Change tests. So up near the top.
10 minutes. Perfect.
Yeah, we're doing great. Up near the top, when you're picking your driver, you can pick Firefox, you can pick Chrome. But
Internet.
you need a plugin for Chrome.
Yeah, and for IE, you can do it on Windows, but you need a plugin for
Firefox comes with
IE, and
Selenium
it's a
support
pain,
right
so,
in it.
Yeah.
But you can also change this to PhantomJS. Run the test again. And it did not start Firefox, you'll notice, and the test passed, and it only took 5 seconds this time.
Yeah, so it speeds it up quite a bit. And you can also run it like we have like dev, stage, production servers, and I like to do my whole test suite on the dev and the stage before I push it out to production. And there's really no UIs out there, so you can run this PhantomJS out on any server that you got. So
right,
it's really
you
good
could run
that
it
way.
on your source code control server and have it do a bunch of tests whenever you check in your code.
I think it'd probably work on Travis CI and stuff.
I think
too,
it'd probably
you
work
know?
on Travis.
Yeah,
So, and then this is just to show that even though it's headless, it still fails in the right way when I write a failing test.
Mm-hmm.
So the last thing is Mark is going to talk to you about running this test in the cloud.
Yeah, so it turns out to set up your own Selenium server is a real pain. And of course, all you guys are working on Macs and whatever, and you don't have access to Internet Explorer. So that's always the bugaboo, right? Internet Explorer,
Right.
everything breaks on it.
Because the day before release, we want to test it on IE, right?
Yeah, exactly. So there's a couple, Sauce Labs is the one I'm familiar with. I think there's another one called Cross-Browser Testing that supports Selenium tests in the clouds. They have all different configurations, all different OSs and various flavors of OSs and browsers and stuff, and you can run against it. Okay, yeah, now our web app is running locally, right? So how the heck is...
And we haven't released yet, so it's not public.
Right, it's hidden. So Sauce provides this tool called Sauce Connect, and it opens up a tunnel to your machine so that they can access it from the web. Now, I've already got that running because it takes a while to fire up. Where is it? There, you can see it says connection established down there at the bottom. And now I'm going to run a different test. Let me open it up. And you set up a little bit different set of what they call capabilities, and you point it at a different test executor that's their text executor out on Sauce Labs. So it's just a few lines of code.
But everything else is the same
What am I
test
gonna
that you
do?
already developed, right?
Yeah, the same test otherwise. Everything's exactly the same. This is my passing test, so this should pass. And I'm doing it Windows 7 with IE 9. So here we go. I'm going to run this.
They support iPads and Android phones, and you can test on all these different things.
Ooh, I forgot to do that. Let me see.
We have a bug.
No, I just forgot to set up my thing. I got shit down. Okay, set. I hope nobody has any didactic memory out there and gets my key. I guess I can change it afterwards. Come on.
There it goes.
Yeah. Okay, and here it goes. Now if I go out to the web there and refresh, oh, there it is. There's something running. Come on, oh, it's queued. Okay, there it's running. Let's go to the full screen view.
We're very lucky with the internet god today.
Yeah, I'm not sure if we're going to do this. And let's see, what's it showing me? So it gives you a nice little screencast showing you it doing stuff here. Oh, is it stalled? Oh, there it
No,
goes.
it's
Okay.
going.
So this is running out at Sauce Labs, IE 9. My bad typing the time I did this. There we go. And I guess that's it. I think it's done. There we go. It's done.
And then it actually records a screencast, so you can go back later and see if your test failed. You can go back and see how bad it looked and maybe why.
Yeah, and what you'll see in my, okay, and in my display here, the tests right now just say finished or error. So if a test runs all the way to the end with no error, it just reports finished. You have to add some code to the test to go out to the Sauce REST API, and you can set the status of a job. So if you want to get a nice big red failed when your test fails, you have to do that after. You have to, when you assert something, you have to catch it and then go to the REST API and change the status of your job. Or if it's successful, you can change the status to success.
But that's
And it
only
looks
if you
great.
care about what's happening on this web page. Your
Right. Your test still reports back failure. Right, see right here, it says, yes, that passed.
Yeah.
By my little dot. Okay, and that's it. So you always get information right there where you're developing and ready to commit and push.
So that's basically the whole setup. We wrote a test. We played with it in 2 languages. We showed it failing. We showed it succeeding. We showed it in PhantomJS, and we ran it in the cloud.
Right.
So this is a way, we think, a really good way to test your JavaScript-heavy stuff, and be able to run those tests in a variety of different ways automatically. That's it. I think we've got a couple minutes. We have 3 minutes,
3 minutes
for
for questions. Anybody? So we expect you to all go home tonight and write one of these tests,
Yeah,
okay?
exactly.
I mean, this is code for the road, so take it with you, okay? Let's see. Everything is out on our my GitHub
We got
repository, mreader, reader spelled strange, R-E-D-A-R, and I'll scroll down and we have the links to all the various tools
There's a bit.ly
here.
there
Oh
for
yeah,
this page.
there's the bit.ly that'll point to here. And yeah, please guys, test your UIs. There you go.
Yeah.
That's it.
That's it. Thanks.
Thank you.
I need that Ethernet dongle that they talked about. Riley was going to come up and give me an Ethernet dongle on the screen.
Riley, do you have an Ethernet dongle?
Oh, actually, I have one in my bag. Never mind.
Thunderbolt 2. Okay. We got it. Do you have sound? I don't need sound. Okay. Stick that in there. And so try desktop presenter now? Okay. Okay, full screen's fine with me.
No.
That's back.
127.
Let's go into that control panel and make sure that.
No, I don't.
we've got that.
No, I don't have. I'm not connected to wireless. I could.
No,
I don't need to be, right?
We need you
Yeah.
connected here in order to get the screen.
Oh,
shared.
geez. Hold on just a minute here.
Should be able to go ahead and start. So, network. Thunder connected.
It's starting now. Maybe.
Okay.
I don't know
The
why.
IP address is.
Is that right? then?
071. Okay.
Okay. So I'm just going to go to the. Just a minute here. Not quite ready. Displays.
I think you already have it for best for display.
Built-in Retina, but I want it to be mirrored.
Oh, arrangement.
Yeah, okay. Mirror displays. And I think I might have it. Yeah. Is that good?
Yeah, you're good.
Okay, so let me just get this out of the way.
Double check.
All right. So our last talk of the day is Birkin from Brown, and he is going to talk about queue programming, how using job queues can make the library coding world a better place.
Okay. So I want to talk about. Right. Good. Okay. Better. All right. I want to talk about a very nice, lightweight tool that we are using at Brown University for queue programming that we started recently using and are very happy with. So I'm going to skip some background and just go right into a brief overview of what a job queue or task queue is and why it's useful. I'll show you a couple examples of a simple example in action of the tool RQ in action, and talk about how we are using it and give some final thoughts. So I'm skipping some background stuff. So in a nutshell, job queues or task queues have three parts. At the core center part is a broker storage layer, and that's where jobs are stored. Then code puts jobs onto a queue. That's the producer, and code perceives jobs on the queue and executes the work, and that's the consumer part. But in the parlance I'm going to use, that's the worker. So last summer, a bunch of us were experimenting with Redis, a NoSQL key value store, very easy to install and play with and experiment with. And then one of us discovered RQ. It stands for Redis Queue. It's a very lightweight Python library that allows you to do two things. It allows you to get your Python code onto a queue very easily and to start up workers in a couple ways that are useful. So why job queues? One thing that you hear is that job queues are good for processing long-running tasks, and that's true, but cron can do that. Really, job queues give you the ability to have a nice blend of responsiveness and scalability. And the responsiveness comes from something else that job queues are known to be good for, and that is parallel processing. So you have a bunch of things you need to do, and you can start up multiple workers to watch a given queue or queues. And so if you have a bunch of things that take any time to do, you can do them, process them more quickly. But the other thing is, even if you have one worker watching a queue, you're getting into the habit of triggering work instead of polling for work, which also improves responsiveness. And the scalability comes in, it's really controlled scalability, that the ability to have multiple workers gives you the ability to privilege the goal of keeping your queue small to improve responsiveness, or depending upon your system resources, because RQ allows you to set up workers in a couple of different ways very easily. It allows you, if you have constrained system resources, you can set up workers in a way that respects those resources while still improving your, while still having the ability to trigger work and improve responsiveness. And it has a couple other examples that are, the job queues offer a couple other benefits that I'll mention. So I'm going to give two examples of a simple example of RQ in action. The first one is going to show that main benefit of parallel processing that people know about and is obvious, and to show you how easy RQ makes it to do this stuff. So in this situation, in this example, I have, I'm going to call a start script. And this start script is going to take a list of works. I have a title and URL to the text. These used to be URLs to Project Gutenberg, but running it a bunch of times, they didn't like that, understandably. So I downloaded the text. Anyway, so I'm taking I'm taking 10 works, and for each work, I'm creating a job. A job is essentially a call to a function and any data that that function might need to do its job. Now, I want to before I go ahead, I just want to point out two things. I have a line here, and you might not be able to read it that well, but there's one line, and that one line shows how RQ makes it easy to create a queue and have the reference to it, or if you already have that queue set up by some other process, that same line gives you a reference to that queue. The other thing at the bottom here I want to point out is that even though I have it broken into 3 lines here, really it's one line. There's one function I'm calling for RQ, one line to call that get keywords function, to get that function onto a job queue. And that line is that enqueue call function is taking the name of the function that I want to run and the data that's sent to it. Very easy to set up. Oh, one other thing I want to point out is I'm referencing that function via a string. I don't have to reference it via a string, but if I do, the nice thing about that is that this code that's creating the job doesn't have to have any knowledge about the actual function in the module that's getting called, which is nice. Okay, so just a brief look at what get keywords is doing in the background. So when I run this, so get keywords is basically taking the title and the URL to the text. I have a little artificial sleep in here to make the output a little more comprehensible. And I'm calling that URL to get the text, it's really text, and then I'm taking that text and sending it to a natural language processing service I set up a while ago to experiment with to get keywords on that text and the keyword, and I'm just printing out the keywords. That's all in this example that's being done. Okay, I'm going to go over to the terminal, and I'm going to start up. I just started up something called RQ Info, which is a very lightweight monitoring tool about which I'll say more in a minute. Now I'm going to start one worker. Okay, so I started a worker. RQ allows you to get workers and Redis. You don't even think about it. You just focus on your work, which is a nice thing. I specified the name of the queue for the worker to watch. You don't even have to give queues names, but if you give queues names, you have a lot more flexibility. So I have one worker run. Typically, workers are started up by scripts. You can set up multiple workers, and you can specify the output of where the workers are logging to. In this case, I'm just doing it via the terminal because it's easy to show. I'm going to set up a second worker. I'm going to fire off that initial script. Okay, all jobs have been put on the queue. Now, what's cool about this, I mean, maybe it's obvious for anyone who's worked with queues, but what's cool about this is if I would have just put 1,000 jobs on the queue, or 5,000, I would have gotten the response back almost that quickly. And it gives some glimpse into that kind of heady, giddy feeling that JavaScript developers know so well by being able to so easily kick off parallel processing. But I hadn't done that before, and it makes me happy. Okay, so now I'm going to go back to RQ Info. That's that very lightweight tool that is built into RQ. And it shows all of your queues. There's one here, the number of jobs in the queue, your workers. I have 2 workers, what queue or queues they're watching, and whether they're idle or busy. So I'm going to continue. 8 jobs left to process. 6, 4, 2, no jobs, and the workers go idle. Okay, I'm just going to go back to one of my tabs where I started up a worker. And if I scroll down through here, you'd see that this worker processed about 5 jobs. The other one processed about 5 jobs. No guarantees about what workers are going to process what jobs, but there don't have to be any such guarantees. So by default, the output of a worker shows the function that was being run, the data sent to that function, and any log output above a certain level, and of course the print statement that I made. Okay, enough of that example, just to show how easy it is to kick off parallel processing. This example, I'm going to go through it. It's about how jobs can spawn jobs. And I'm just going to go through it and talk about why I think it's really cool, and it's less obvious why it's really cool, but I'll just go on. So when I kick this start script off, it's going to create one job calling a function called run first task, and it's not going to send any data to the function. That's all it's going to do. So in the background, and you'll see that this code is exactly the same as the first example's code. It's just refactored to illustrate my point. So I have a task class with 3 simplistically named functions: do first, do second, do third. I'm making a point here. So it's so the first function, do first, is basically just returning that list of works. The second function is taking a URL to the text and is just getting the text and returning the text. Third function is taking the text, doing the NLP service keyword lookup, and printing out the keywords. I have a fake error in here, about which I'll say more in a minute. That's foreshadowing for the humanities people among you. Okay, so where's the Q stuff? There's no Q stuff here. Well, that's because a common pattern when using 5 minutes. Oh, good. Because I can talk fast. But okay, so a common pattern when using RQ and you want to call a function that's a function in a class, a common pattern is to call a wrapper function, and when I start the job, it's going to be calling this function, run first task. Now that lets you do things like set up a logger that you can pass to a class instance. And so here it shows that I have a class instance and I'm calling that first function above, and I'm getting the works dictionary. And just like before in the start script, I'm putting this job is doing the work of getting the works dictionary, and then it's creating 10 jobs. Run second task. Run second task is going to take that URL to the text and get the text. That's the work, and then it's going to create a job. That third job is going to take the text and do the keyword stuff. Now, the nice thing about having the task separate, at first I was a little disappointed that I had to have a separate wrapper function, but the nice thing about that actually is that you have your task class and functions that can be accessed from other parts of the application without any queue dependencies. You can run your unit tests like you normally would, so the queue's there in the wrapper function if you want it. It's not there if you don't need it. Okay. I'm going to go back to the terminal. I'm not going to start up RQ info this time. I'm starting up something called RQ dashboard. RQ dashboard is a third-party library, very easy to install, that uses RQ, and it has a built-in web server that gives you a nice interface into a monitoring tool that does a couple cool things. So I just started up one worker. I'm starting up a second worker. You can see the worker starting up here. This thing that looks like a pause button, it just shows that they're idle. I'm starting the job. Okay, I'm pausing it. One task. Remember, one task I put on the queue in that case, and it's now going to kick off 10 tasks. So you see that this play button indicates that now one of the workers is beginning to process a job. Okay, that one job has kicked off 10 jobs. Now, you can't see this, but this number 8 shows the number of 8 jobs on this queue fun queue. It's static, it's not changing, because in this example, one job as it finishes is creating another job. And now I see failures. So this artificial failure is meant to represent a service being down or a bug in your code. So I go back to my code. I'm fixing it's 1 divided by 0 if you can't see it. I'm fixing the error, or let's say imagine the service is back up. And now I'm going back to RQ dashboard. And I'm just making a little space in the terminal for output. But going back to RQ dashboard, and I want to point out how the listing of queues, I know it's small, but the listing of queues shows all your queues, in this case the failed queue. I can click on that, and when I click on that, I see all of the jobs on that queue, which is nicer than you might think, because remember these, if I had to look in the regular worker output, I don't know which worker, is processing the job. So this puts all of my jobs in one place. It shows the particular function that's being run on the failure and the data passed to it, and I get this nice trace back, and I see the zero division error. But in true Ronco fashion, wait, there's more. And in this case, I don't even know if Ronco's still around, if anyone knows what Ronco is referring to. But anyway, I have these buttons here. I can cancel the job, I can requeue an individual job, but in this case, I'm going to requeue all the jobs. And when I requeue all the jobs, this queue list here, the failed queue is going to go away. It's going to be replaced by that queue fun queue. And then you'll see the jobs processing away. 8 jobs left, 4 jobs left, 2 jobs left. No jobs left, and the workers go idle. Okay, why is that cool? It's cool because parallel processing is an obvious use case for these multiple workers. But imagine in one of your jobs, you have a very complex workflow where, very complex workflow where some of the steps are expensive to run. And if you fail down here, you don't want to have to rerun some of the expensive steps. Or maybe one of the steps involved notifying a user about something and you don't want to have to do that again. If that's the case, you have to track the processing of that job along the way so that when you rerun the job, which you have to do because it failed, you don't do stuff that you've already done. If you already have separate functions for those pieces of work, you can just enqueue those functions and put them on the job queue. And you don't have to track everything. You have your failed queue. Once the service is back up or you fix your code, you can easily requeue the jobs. It becomes very powerful to be able to break to, and many people might think, well, you can process things concurrently, but if you have tasks that depend on other tasks, you can't really use a job queue for that. But you can. 5, okay. 5, that was 5, okay. All right, so how are we using this? Brown Digital Repository. One thing that we do is, an object gets ingested into the Brown Digital Repository. Fedora fires off a Java messaging service message. And for a couple years, for a bunch of years, we've had a listener that listened for that message and kicked off solarization of the metadata. Probably everyone does something like that. We've changed that, so now that listener kicks off a job that does the solarization. Tiny difference, but it gives us 2 things. One is since we've decoupled the object going to Fedora from the solarization, we have a lot more flexibility to resolarize a collection if we have to without having to touch the Fedora objects. But the other benefit is that every once in a while we had a little bit of drift in our solarized metadata from the true metadata in Fedora. Why? Every once in a while, like Tomcat might hiccup, so it might be down temporarily, or occasionally there's a collection that has unusual metadata and the code has to be tweaked a little bit to do the solarization. If that happens now, so the initial solarization fails, nothing's lost. The fix can easily be made, and as you saw, we can pick up where we left off. Streaming objects. Another use case is that we do is we ingest into the BDR, the Brown Digital Repository, master videos. And maybe a month or 2 later, the BDR team will get a request for a particular collection to create derivative objects with customized rights data and optimized to work with Brown's streaming video service. And whereas in the initial solarizer, in the solarizer example that I gave, those workers are started up. There are 2 or 3 workers that are always watching for jobs, and those workers are in daemon mode, living in perpetuity. In this case, in this workflow, typically the BDR team will get the make derivative code ready. If there are 500 objects, get the object IDs and create 500 create derivative jobs on the queue, and then they'll fire up workers in what's called burst mode. Burst mode is it's as easy to start up workers in that as it is regular workers. The difference is those workers, their lifespan exists until the queue is empty. The neat thing about that is you can combine those 2 ways of starting up workers, so you can have a service where your normal workload is handled by one or two regular workers, but at the beginning of a semester, or if there's some big project and you get your workload gets heavy, you can start up one or two workers very easily in burst mode and walk away knowing that once your queue's processed, your architecture goes back to normal without you having to do anything. I'm going to skip this example and mention a couple final tips. What do I have here? 1 minute? Okay. Okay, I'm just going to go back down to this one tip here that's a useful thing. Tracking. Sometimes you have a need to have to track final disposition of objects. If you have parallel processing, like you might need to go like a final disposition, object 1, success, object 2, whatever. If you have parallel processing, you do have to worry about race and overwrite conditions, but you have Redis right there. You have a Redis Python library that RQ installed. Redis has a hash data type. So you can simply say that your project name is the key to a Redis record, and the value, the hash data type value is object 1, success, object 2, whatever. And multiple things can write to that without you having to worry about any race overwrite conditions. Using job queues makes you think about triggering work and possibilities open up that you wouldn't have thought of. Just last week, I created a button for an admin to initiate a long-running task via the web. She gets back a response saying processing started. I wouldn't even have thought of doing that before without being able to put it on a job queue. In closing, I'll just mention that we are fortunate in our realm to have an enormous number of interesting tools to play with, some of varying degrees of utility. This is one that's really useful and really fun. I encourage you to check it out, or its cousin in the Ruby world, Rescue, which also uses Redis as a backend.
Yep. Okay, so we have a little bit of housekeeping. Just a reminder, tomorrow's our last day. Aw, sad. We will have our closing keynote by Valerie Aurora. Did I pronounce that right? I've always wondered. I've even met her. You'd think I would ask. We'll also be doing more lightning talks. I think they're all full. And then a few presentations as well. Tim has some announcements.
I just have one announcement real quick. I'll be doing thanking the volunteers tomorrow, but one of our volunteers won't be here tomorrow, and I want to make sure I point him out. Riley Childs in the back there, waving his hand. So many of you may not know this, but he's playing hooky. He's skipping school. He's actually a high school student who found us over the summer and has joined our community. And so I think, other than his, giving him a round of applause like we just did, I hope that maybe one of us can, or many of us can go back to our campuses and see if we can get him a full scholarship somewhere when he starts looking for colleges. So, because I think he has a bright future ahead of us. So you can find more about him at rileychilds.net, and he actually does a library tech cast that you can check out as well. So thank you again, Riley, for all your hard work this week. We appreciate it. Have a great night.